Buckle up! In this video, you'll fly over surreal landscapes shaped by giants from another era and discover Europe traversed by a giant river that alternated between periods of awakening and slumber for millions of years. North America crisscrossed by torrents of water more powerful than those of the Amazon. North Africa plagued by ephemeral titans that regularly appeared in the desert before dying there soon after. During this hallucinatory journey, we will even discover monsters formed by the thaw, responsible for apocalyptic floods that ravaged the landscapes, carving the rock dozens of meters deep in just a few hours as they passed, and taking a detour to another planet to venture into dried-up canyons carved by extraterrestrial torrents. We live on a world we think we know, mapped, measured, and charted down to the last square kilometer. But our maps of the Earth are just snapshots of the constant transformations of our continents and the major shifts in climate. Beneath the landscapes of deserts, forests, and farmlands that we tend to think of as unchanging, excavations reveal traces of gigantic ghost rivers that once irrigated and shaped entire continents before disappearing. Let's begin our journey without further delay with a colossal river that ruled over a vast part of North America for nearly 47 million years before disappearing. The story of this river, named Paleobel, begins at the start of the period known as the Eocene, 50 million years ago. North America was then free of any permanent ice cap, and the immense Hudson Bay had not yet been pressed down by the weight of glaciers. In the high Canadian latitudes, where the taiga or tundra reigns today, the climate was overall much warmer and more humid than it is now. And the regular rainfall that comes with it, which abundantly waters the entire continent, will give rise to a river network larger than the Amazon today. This giant river from another era, which then flows northeast before emptying into the North Atlantic. And it extends its hydrological network from the Great Plains to northwestern Canada, probably incorporating into its network regions as far away as Colorado. When these multiple tributaries, moving toward the mouth, reach the gentle slopes and the time-worn hills of the Canadian Shield, they spread out, giving rise to something that looks less like a single giant river and more like a braided river network of hundreds of branches, winding lazily through vast alluvial plains covered with wet forests. For tens of millions of years, this giant hydrological web, dotted with shallow lakes and swamps, forms a sprawling, ever-shifting network. Yet, even though the interlacing rivers are regularly reshaped by occasional floods, climate variations, and the movement of tectonic plates, the position of the outlet point hardly ever changes. And for 47 million years, all the rainwater that falls in this region of the world and manages to escape evaporation ends up here in the North Atlantic off the coast of Labrador, where these millions of years of continuous flow eventually produce a truly monumental delta. At this great outlet, the conveyor belt of water, sand, and mud taken from the continent gives rise to a delta nearly 50 times larger than the Nile's today, and in which the giant river splits into a multitude of secondary branches that regularly overflow their banks and snake nervously through. Landscapes where vegetation struggles to take hold before the river reaches the sea, where the many waterways are constantly pouring out. More material than the ocean can then carry away. The discovery here of the Saglek Delta, which has since been reclaimed by the waters, is the most spectacular proof of the existence of this ancient network. There, drilling has revealed the presence of millions of cubic kilometers of sediments deposited by the river, which now lie at the bottom of the ocean. And then, after 47 million years of existence, when the Quaternary period begins and temperatures start to drop, the flow of the rivers feeding the Paleobel River decreases. And above all, the gradual appearance of ice caps in the landscape will disrupt the system. Here and there, walls of ice create barriers. Major river connections are broken, others are diverted, and this continent-spanning river system is then gradually dismantled. To give you an idea of the upheaval caused by the formation of ice caps during the Quaternary, which could at times cover almost the entire North American continent with several kilometers of ice, we'll compare two maps. On this one, you have a rough representation of the layout of the main rivers that flowed in North America about 3 million years ago, just before the formation of the ice caps. And here is their current layout. This absolutely radical reconfiguration is the result of the alternating formation over nearly 2.5 million years of the immense North American ice sheet prevented rainwater and meltwater from flowing north, forcing rivers to find detours to reach the sea. In short, rivers don't always die of thirst. Some disappear when the earth moves their sources. Now let's cross the Atlantic to discover one of the most powerful rivers Europe has ever had, the Eridanos, which formed on the old continent. 20 million years ago, at a time when Europe was finally stabilized and ready to welcome a giant river system. Because during the tens of millions of years that preceded, the European continent was far too fragmented and broken up into short-lived inland seas, and constantly reshaped by the violence of upheavals, making it impossible to host a giant river for any length of time. But at the beginning of the Miocene period, things started to change. Just like the Paleobel system, the Eridanos was born in a world that was generally much warmer and wetter than today, and where the ice caps had not yet locked the pole. And for nearly 20 million years, this system, which spreads its tentacular web over almost all of Central and Northern Europe, reaching into the foothills of the nascent Alps, would become one of the largest hydrological arteries on the planet. Because this river and its tributaries then formed a watershed of nearly 1.6 million square kilometers, in which vast rivers meander through landscapes of warm temperate forests to subtropical ones, sometimes even through lush marshy areas, before joining and converging to empty out where the North Sea is today. Then, after the drop in temperatures and the arrival of ice in the Quaternary period, the Eridanos was gradually dismantled by the gigantic glaciers of northern Europe, which blocked or diverted its waterways. But unlike the Paleobel system, shortly after being broken up, this European giant would be reborn almost immediately in another form and in unrecognizable landscapes. Because the ice caps, several kilometers thick, which form at regular intervals over the British Isles and Scandinavia, will give birth to a new giant, a sort of successor to the Eridanos, which shifted between two radically different states. During the glaciation phases, which last on average between 40,000 and 100,000 years, the giant river is in a state of hibernation during the winter months. Because it is so cold then that the meanders carved by this sleeping giant, which lazily winds through landscapes of frozen steppes and windswept tundras, only carry thin streams of water. But during the summer months, in the short thawing seasons, when the summer temperatures briefly rise above zero, the dormant system awakens from its sleep. The surface melting of the ice then, for a few months, gives rise to an immense network of rivers, which regularly overflow into the vast European plains, and they come together to give birth to a giant, short-lived river that seeks to reach an ocean to empty into, following the curves of the landscape. This alternation between phases of hibernation and awakening, which, with each melting season, profoundly shapes the landscapes, repeats itself for thousands of years, until the temperatures suddenly rise, and we begin the transition to an interglacial period. And after sometimes spending tens of thousands of years flowing in a dormant and relatively reduced state, the system, which enters a phase of hyperactivity, is then suddenly brought back to life by the overwhelming power of raging meltwater, which causes the river and its tributaries to overflow their banks. In some places, the runoff water flow increases by a factor of 100, and the flood rivers, unleashing their raw fury, then carve deeply into the thawing landscapes, redrawing the river networks with the power of their torrents of water, mud, and sediment. Then, after a few centuries to millennia of upheaval, once most of the ice has melted, a period of stability begins, a return to normal, typically lasting from 1,000 to 20,000 years. Before the biting cold and glaciers return, reducing the amount of liquid water flowing through the north of the continent and plunging the system once again into a succession of hibernations and brief awakenings. For several 100,000 years, during the glacial periods, the waters of much of Europe found access to the ocean through the North Sea. But 1,000 years ago, the formation of a massive ice cap, which then connects the British Isles to Scandinavia, prevents these deep waters from flowing into the Atlantic by the route they had used until then, blocked in their northward progression by a huge wall of ice, and to the west by the rocky barrier that then connects Great Britain to the rest of the continent. These waters accumulate and, in just a few centuries, give rise to a vast glacial lake, which, as it keeps filling up, eventually overflows to the west and continues its course along the bottom of the channel, which is then exposed to the open air. Because during the marked glaciation phases, the level of the world's oceans is nearly 120 meters lower than it is today. During glaciation phases, the waters that accumulate in this impounded lake will even, on several occasions, they manage to partially break through the natural dam connecting Great Britain to Europe, suddenly releasing truly enormous amounts of water into the bottom of the English Channel. Then, about 15,000 years ago, after spending nearly 2.6 million years falling asleep and waking up, these intermittent flows will finally come to an end, in one final grand finale, at the end of the last glacial maximum. In just a few millennia, temperatures rise sharply, and the veins and arteries of the river system are then swollen by the melting of millions of cubic kilometers of water trapped in the glaciers. Again, for several millennia, at the mouth of the system, the rivers merge into a single, more powerful flow to give birth to a water monster, which flows more than 100 meters below the current ocean level and empties into the North Atlantic, hundreds of kilometers further west. To try to imagine the absolutely insane quantities of water that could surge through this narrow region during the summer, consider that it is estimated that the flow of this roaring river was nearly 3 times greater than the combined flow of today's largest European rivers. Then, strangely, about 10,000 years ago, with the acceleration of warming, this river lost some of its tributaries, and with them much of its grandeur. When a large part of the meltwater that fed it began, as the glaciers retreated, to flow into the ancestor of the Baltic Sea, located a few thousand kilometers east of its mouth. In this region of the world, a lake as large as a sea was being born. But perhaps the most impressive thing is not that, because during this deglaciation, as in previous ones, the thaw and the weakening of the soil regularly cause the breaking of natural dams that trap the ephemeral lakes which have formed all over Europe. During these sudden drainages, the flow at the exit point of the English Channel can, for a few weeks, reach nearly 1 million cubic meters per second, which is roughly equivalent to 5 times the average flow of the Amazon today. Or if you prefer, that's 25 times the flow of the Congo River, or even 50 times that of the Mississippi. Inevitably, as sea levels gradually rise, the mouth of the mega river is reclaimed by the sea. And when the last ice age ended about 100 years ago, the river disappeared, submerged by the rising waters to which it contributed. If the traces of these phases of brief flooding have here been erased by the return of the sea, to the point that they can only be seen in seismic surveys, there is a region where the effects of these events remain clearly visible. To see this for ourselves, let's cross the Atlantic again to discover a cataclysmic river, which is probably one of the most violent episodes that water has ever inflicted on a continent. The story of this river begins with the birth of a gigantic and unstable lake, because it was held back by ice. We are at the end of the last ice age, at the moment when the flow of the European giant was at its peak. The thick tongues of ice from the North American ice sheet that invaded the valleys of the northwest United States formed a colossal glacial dam there, behind which Lake Missoula was created. For decades, this lake slowly accumulated meltwater from the surrounding glaciers, eventually holding up to 2,000 cubic kilometers of water, a volume comparable to that of the Caspian Sea. The pressure exerted by this colossal volume will break the ice dam that traps the lake. When the wall gives way, it suddenly gives birth to a short-lived water monster. Based on the size of the debris moved by the disaster, it is estimated that the flow of this ancient torrent must have been 10 times greater than that of all the current rivers on the planet combined. Or, if you prefer, nearly 100 times greater than that of the Amazon at flood stage. These truly astonishing values make this ephemeral river the most powerful flow of fresh water ever documented on Earth. Even today, everywhere this wall of water, which could reach 100 meters high, passed through, the landscapes have been carved by its violence. Floodwaters that rush down the slopes at speeds of around 100 kilometers per hour, carrying with them millions of tons of rocks and sediments torn from the ground as they moved forward. Throughout the state of Washington, western Oregon, and through the Columbia River Gorge all the way to the Pacific Ocean, we can find traces of this flood imprinted on the landscapes in the form of abruptly carved canyons, stripped cliffs, and rocks weighing several dozen tons that were either pulverized or deposited on the summits of hills, or even plains that were scraped and smoothed by the passage of the raging floodwaters. All these features could only have been formed by the sheer power of a giant wave carrying blocks of ice and sediments. And this astonishing event happened several times, because after each break in the ice dam, the ice cap would once again close off the outlet within a few decades, and Lake Missoula would gradually fill up until the wall gave way again. In this way, evidence of about 10 of these flood phases has been identified, between 15,000 and 13,000 years ago. Then, after spending 2,000 years intermittently scouring the Earth, these ephemeral rivers disappeared for good, because, as the ice sheets retreated, the waters of Lake Missoula stopped accumulating, finding other, less chaotic routes to reach the sea. The Missoula floods are absolutely fascinating. I've really given you a broad overview of the violence of the event, but if you want to dive deeper and see more images about this astonishing story, you'll find here a video I dedicated entirely to it some time ago. Surprisingly, Earth is not the only one to have been affected by the passage of ephemeral rivers on its surface. In fact, we can find the traces left by events even more impressive than those of Missoula. Etched into the surface of Mars, at the far east of the gigantic Valles Marineris system, which scars the red planet for nearly 4,000 kilometers, there is a strange formation. A dry and dusty canyon, far more imposing than the most impressive ones on our planet. Named Chasma, this strange structure, 3 to 5 kilometers deep, up to 100 kilometers wide in places, and stretching for about 1,000 kilometers, was carved by water flows of absolutely colossal scale. And I choose my words carefully. It is believed that Chasma was formed by brief and incredibly violent floods, involving volumes of water tens or even hundreds of times greater than those released during dam breaks, the Missoula floods. And these truly extraterrestrial deluges raged several times during the youth of the planet Mars, to the point of eventually reshaping an entire portion of the end of the largest tectonic scar in the solar system. What's particularly strange is that the phenomenon behind these flows has no equivalent on Earth. Indeed, this Martian river, as brutal as it was short-lived, did not owe its birth to torrential rains or the breaking of a natural dam. It comes directly from the depths of the planet. When Chasma began to be carved 3.7 billion years ago, Mars already had almost no liquid water left on its surface. But that doesn't mean it has completely disappeared from the planet. A large part of the water hasn't yet escaped into space. It is then stored deep underground in the form of ice or as trapped liquid. Now, during this period, the gradual opening of valles marineris will cause the formation of gigantic fault systems, which will depressurize and awaken some of these dormant pockets of water. Because when the crust fractures, the pressure on the deep aquifers drops suddenly, and the massive underground water reserves then rush upward at full speed through these open wounds, from which they gush out like geysers, instantly forming on the surface of Mars. Unleashed torrents, cataclysmic floods moving hundreds of thousands to millions of cubic kilometers of water, literally devastating everything in their path. For a few days to weeks, until the reservoir exposed to the open air is completely emptied and everything returns to silence. Before it starts again, when a new fault opens up, revealing a new reservoir. It is the intermittent repetition of these monstrous draining phases over hundreds of millions of years that eventually carved out the colossal canyon of Chasma. A canyon that allows us to observe the activity of a river, a witness to a once wet past that is now gone. Irrefutable proof that Mars was once a hydrologically active planet before turning into the frozen desert we see today. Let's now head back down to Earth, heading to the Western Sahara, where the remains of a river have been found buried under the sand, so vast that its network could have formed the 12th largest watershed on the planet if it were still flowing today. Over 1,000 kilometers long, the Tamanrasset River has the strange peculiarity of having experienced dozens of deaths and rebirths over nearly 2.6 million years. Throughout the Quaternary, during the interglacial periods, the African monsoons, which manage to penetrate deep inland, break against the highlands of the Atlas, the Aire, and the Hoggar, turning these rocky islands, lost in an ocean of dunes, into water towers. Watered by recurring rains, they give rise to river networks that interlock with each other to form the Tamanrasset. A continental-scale river that, for thousands or even tens of thousands of years, then slowly winds its way through a mosaic of landscapes, savannas, dotted with shallow lakes, and even swamps, before finally flowing into the Atlantic. Then, each time the ice sheets return to the high latitudes, the African monsoon loses strength, rainfall becomes scarcer, the channels dry up, and the river's flow fades away. For tens of thousands of years, the once lush landscapes are then replaced by a dry mineral world dominated by wind and dust, until we enter a new interglacial period and the river, fed by monsoon rains, rises from its ashes. In total, over the 2.6 million years of climate oscillations that characterize the Quaternary, it is estimated that the Tamanrasset was killed by the desert and brought back to life by the rains more than 60 times. Surprisingly, the Tamanrasset never recovered from its last extinction. Because with the end of the last glaciation 100 years ago, global climate patterns were profoundly disrupted. The monsoon periods became shorter and more irregular, and as they retreated southward, losing intensity, the river's tributaries became disconnected from each other, like so many severed nerves. And the Tamanrasset began to fragment, transforming over the millennia into a succession of intermittent rivers and then into wadis, until the system eventually disappeared completely. That was 5,000 years ago. Today, all that remains of the Tamanrasset is its skeleton, which can be seen buried under the sand, thanks to radar imaging methods that allow us to see through the dunes. And it shows us these drainage networks, which, beneath the desert, are sometimes used by underground water, following the shapes of these fossilized sediments. The past existence of the Tamanrasset is also revealed by the presence off the coast of Mauritania of the Cap Timiris Canyon, an underwater incision several kilometers deep, which was carved over time by the power of sediment-laden waters that used to flow here. More than 4,000 kilometers away, the remains of the Sahabi River have also been found, buried beneath the desert landscapes of southeastern present-day Libya. This river stretched nearly 2,000 kilometers into the African continent, draining waters as distant as those from the Chadian highlands. This river emerged in the middle of the Miocene, 15 million years ago, when the Sahara was fed by widespread tropical rainfall. And for nearly 8 million years, its network of branches, winding continuously through a mosaic of savannas, vast grassy plains, and inland lakes, made it the only major African river to flow into the Mediterranean. Until its mighty neighbor, the Nile, managed to reach the sea in turn, 7 million years ago. The Sahabi River was then at its peak, and at its mouth, it probably had a flow equivalent to that of the present-day Nile, fed by a drainage basin of more than 1 million square kilometers, an area equivalent to that of the gigantic Lake Chad, which, further south, was then the largest freshwater body on the entire planet. Then, the climate gradually changed, and the Sahabi lost its splendor, because the gradual cooling of this region, which weakened the African monsoon, slowly reduced the rainfall, and the river, which began to lose its tributaries one after another, was gradually reduced to shreds, while the nearby Nile, which has its headwaters in the rain-soaked highlands located further south of the Sahara, manages to persist. And after millions of years of decline, when the great glaciations began, 2.6 million years ago, the river, defeated by the Saharan aridity, disappeared permanently from the surface of the earth. Now let's turn to a giant whose disappearance, much more recent, may have brought about the decline of a great civilization. The Sarasvati is a mythical river mentioned in the sacred Vedic texts, whose geological reality was discovered in the last century. Originally, the Sarasvati river basin covered nearly square kilometers, an area comparable to river basins such as those of the Rhone or the Colorado. Nearly 1,500 kilometers long, this river was fed by the summer meltwaters of the Himalayan glaciers and by monsoon rains, which, from the regions located in the northwest of present-day India and eastern Pakistan, flowed through the plains of the subcontinent before joining the Arabian Sea. Described in the Vedic texts as a powerful river, with sometimes impetuous behavior, the Sarasvati turned out to be a fragile river, which flowed for only a mere 10,000 years. For the inhabitants of the Indus civilization, which appeared in this region of the world in 5000 BC, the Sarasvati played a role almost as central as its imposing neighbor, the Indus. With its silt-laden waters, it irrigated thousands of square kilometers of fertile plains, and for nearly 1,000 years, humans honored it and benefited from it. But about 4,000 years ago, following major landslides that diverted some of its Himalayan tributaries to other rivers, the Sarasvati began to shrink extremely rapidly. In just a few centuries, it turned into an intermittent river, surviving only during the rainy season, leaving behind an entire civilization bereft of one of its rivers. And a millennium later, all that remains of it are temporary rivers that dry up quickly, and the cities located on their banks are abandoned. Once praised as a goddess, the Sarasvati is now nothing more than a buried memory beneath the sands of the Thar Desert. The earth does not erase its rivers. It diverts them, dries them up, or buries them. No matter how mighty it is, no river is eternal. The paths taken today by the Nile, the Amazon, or the Mississippi are only temporary snapshots, taken from a much larger album filled with landscapes where water was forced to take other routes. No matter how powerful they were, all the rivers we've just talked about simply disappeared because the world around them changed. Their colossal arteries were diverted by the movement of tectonic plates or by the advance of an ice sheet, dried up by changes in atmospheric circulation, and sometimes even drowned under the seas. And yet, the The memory of these vanished giants has reached us through the traces they left in the rocks and in the landscapes. And their legacy is revealed to us as soon as we undertake drilling campaigns or examine seismic profiles. Sometimes we even live exactly where these giants from another time once flowed. In India and Pakistan, in some places, the layout of wells and villages follows the location of the ancient beds of the Sarasvati. To benefit from the groundwater that still flows there, and from the richness of soils enriched with fertile silt deposited by the river during its flood phases. Finally, in closing, let me share a fun fact with you. If you see on a map a river or a stream that crosses a mountain range perpendicularly, then in almost all cases, that body of water has existed for much longer than the mountains surrounding it. On your right, you'll find a playlist with other videos about the mind-blowing landscapes from our planet's past. And if you have a few seconds to spare, I'd be really curious to know if you know of any fascinating forgotten rivers that I failed to mention, and if there are any similar topics that I haven't explored yet.